Welcome to the CheckMate Lasers demonstration videos. This particular video will be going through a complete demonstration of creating a image inside of CorelDRAW, assigning the different parameters to that image, and then bringing it into our XM8 Draw to assign the power, speed, gap settings, which all be explained while we do that, and then saving that file and sending it to the laser machine. And then the demonstration video will cover what to do when you get the object that you're going to engrave and or cut on the laser machine, what all the switches buttons mean as you process an image, and of course we also want to cover the different accessories and components that make up the laser machine and the features and functions that are available. So it's going to be a complete demonstration from starting with an image all the way to a final piece and the laser machine in general. Alright, let's start the demonstration with launching CorelDRAW. In this case, I'm using CorelDRAW X6 64-bit. Really doesn't matter what version of Corel you use. The lowest number I've seen used on a regular basis has been 9 and 10. You can use all the way up to X6 and pretty much any vector-based program such as AutoCAD, Illustrator, etc. Now, normally we'd create an object here, so let's start off with a new page. And I'm going to match up the King's 1200 by 900 table size. I'm going to use RGB as my color preference, and I'll do 300 dpi. Okay. So once we open up the page, I'm going to import a file that I've been working on. And actually, it's probably easier if I just open up the file. Okay. And this is the XM8 Lasers logo. And what I've done is created a file with 3 different colors. Each object can be assigned a color regardless of what that object is. So in this case, it could be assigned black, dark green. In this case, I'm going to use blue. And the reason why I'm doing this is that most designs are going to have 2 colors. Black will typically always be your engraving color, and red will be your cutout color. And I'm adding in a 3rd color here just to show that you can add multiple colors in a design, because there are some specific instances where you do need multiple colors. Maybe you want to cut out this outside logo completely, but you only want to etch these insides areas just to give you an etching into the material, but not cutting all the way through. So there are different reasons why you would use multiple colors. It's not very common, but the ability is there if needed to be used in that manner. Okay, so I've created an object. Overall, it's 4 inches in size, and the object has engraving and coloring. And to assign a color, it's just a right mouse click on the particular color you want to assign it. In this case, I'm giving it the color red, and down here we have the blue outline on the object manager, shows us those different objects. This group of 6 objects is my text. Okay, each individual color or each individual letter is the word lasers. Okay, so let's go ahead and save this file. Save. And I've given it a file XM8 Lasers, and it automatically gives an extension CDR. And I'm going to export this out in a DXF format because that is the most compatible version that I've come across of all the formats that could be used to laser with. And the reason why DXF is a handy format is the fact that it's a AutoCAD format, and DXF stands for Document Exchange Format, and that format maintains all sizes, angles, distances, lengths, etc. extremely accurately. And so that's a necessity because many times you're working with something that has to be an exact size. So DXF maintains those figures very accurately, and so that's the recommended format we suggest that you export your design as when you bring it into our software to run the laser. Let's go ahead and export that. I'm going to overwrite what I've already done earlier. Okay, and because I've set these settings earlier, those become my default now unless I choose to change them. And there's multiple formats of AutoCAD from release 2.5 all the way up to AutoCAD 2008. I tend to use 2000. I've tried all these formats with different programs and different applications, and I find AutoCAD 2000 to be by far the most compatible across the board with all vector-based programs out there on the market. So I highly recommend you stick with the AutoCAD 2000 version, and we're going to use inches, and you always want to export as curves. The reason why is that there are times when somebody will provide you an image that you may not have that same font installed that they used. If they export as a curve and send it to you, your curve, your text, this laser is a good example, will look exactly as they created it. There would be no changes to the object. Okay, and everything else stays the default. Now that we've exported our design to DXF format, we're ready to launch XM8 Draw, which is our standalone interface to control our laser engraving system. And the page right now is set up to 900 by 120 centimeters, which is the size of our table area within the King machine. And we're going to bring in the file into that page layout. Okay, XM8 lasers.dxf, bring that in. Now we can look right here on the right hand side. This is our color layers. The layers that we assign are objects that we assign colors to within CorelDRAW. Now initially we wanted the black to be engraved and we want the red and the blue to be cut. As you can see, they're all assigned by default. They came in as engraved, which is not a big deal. We want engraving to always be first, so the black words laser, we're going to put that up in the order we wanted to process first. Second thing we wanted to do is cut out those center triangles and those center circles, but we don't want it to engrave, obviously. We want it to cut. So just click on that drop down arrow right there and select cut in there. Same with the red, we want that to cut out. Okay, so now that we've assigned what we want those colors to do, and again I can choose in here and tell it that blue, go ahead and make that red, and that one as well. And now we only have two colors. We're definitely going to engrave first, then we're going to cut second. So the reason why I showed earlier these particular objects to be one different color was to show that, let's say we don't want to cut those all the way through, you can assign two power settings to the same color. Each color is allowed one power setting. So in this case, if we want to just etch it out so it's deep into the material but not cutting all the way through, we'd want to give it a different color so we can assign different settings to it. Okay, and let me show you how that works. We're going to put black as the first color to engrave. We definitely want that to engrave first. We want the blue to cut second. And right here I'm going to give those settings too, and then we want red to cut last. Now let me go over those dialog screens to show you what that assignment of properties means when we want the engraved objects, the word lasers, to engrave. I set this to 800 millimeters a second, and so that's the speed the machine's lens assembly is going to move left to right to produce those letters. I'm using 25% power of a 130 watt laser tube, which comes out to roughly 32 watts of power. Okay, so there's my speed. My power, last thing is gap. What that means, and that only refers to engraving application. When the lens assembly goes to the right, drops down a certain distance, goes to the left, drops down a certain distance, goes to the right, it does that number all the way back and forth as it's creating the word lasers. That distance of drop between the next line to pass is what that scan gap refers to. Since I'm utilizing a lens installation that is 7/1000ths of an inch diameter, 0.08 is ideal for those two line passes to blend or gradient together perfectly to give us a solid image the way we want it to engrave. So this scan gap, you can make a very large number, which would give you very distinct separated lines, or a very small number, which would make those lines overlap. You decide how you want that to come out. Now going across the image itself, your objects automatically know how many, the laser automatically knows how many times to fire the beam to create that object, but it's a drop down scan gap distance that it needs to know how tight you want that image to be. Okay, then let's go to the cutting application, the cutting dialog box, and this is a blue, of course. We're going to assign for the blue to cut out, we're going to have that cut first and then the red second, and I'm going to use a 10% speed of cutting. And power, I'm going to use, 10 millimeters a second of cutting. That's the speed we're going to run at. And for power, we're going to use 85% power to cut through a straight line. And then we're going to tell it, when you hit a corner, back the power off to 75%. Okay, what that means is that it's going to start where this little yellow dot is. It's going to go towards this arrow right here shows you the direction it's going to go. So as it comes up to this point, it's changing direction, corner power, and it's going to drop down. But it's a little pause right there for a split second that it's going to heat up that corner at 85% power. May be excessive and may burn that area too much where you don't get a nice clean straight edge right here, but you get a rounded edge. You back off that power slightly to 75, 70, 65, whatever you find works best for the material you're working on, and that power will be backed off when it changes direction. So as it comes back down here, it also hits this corner and drops the power again, because once it changes direction, the power goes back up to 85 until it hits this corner direction and it drops back down to 75 again. It'll do that on every instance of a direction change the power to be backed off that much to what you've set in there. Ideal for cutting in areas that are very tight, like here. It's so close here, the beam's heating this area up quite a bit, so that backing off the power gives you a much cleaner edge quality. Okay, so let's click OK on that. Now, the next thing we want to do is make sure they're in power speed settings set for our material. It's also set for the order that we want it to process. The other thing we want to do is looking at this define cut route is where do we want that yellow dot to begin? You can start the yellow dot anywhere on the screen on the object you want it to start. And what that means is that the beam will start cutting there, and it's going to, you can see the little arrow there, that's the direction it's going to travel. So it's going to go to the right, come all the way around to the object, and it's going to end right back here. Same thing here. We can set the starting point up here, down here, anywhere on the object. That yellow dot needs to be where you want it to start. Okay, now when it comes, now that's for just for cutting. When it comes to engraving, even though we have the yellow dots on the word lasers, that's irrelevant because we're not cutting out those letters. We're going to engrave the whole thing, so that's going to be ignored. The last thing I want to make sure it's set is my origins position starting. In other words, when I put my lens assembly in on the material in the laser machine, I want it to start right here in the center of the object. Okay, and what that refers to is assuming I have scrap material and I'm not quite sure if I can utilize all of it. So I want to do a test run, and on the laser machine there's a test button to determine if the object has a will fit on the material that we have used in the machine. Okay, in other words, in previous days, scrap material typically got thrown away. It was just too much trouble to measure out the material, measure out your design, position it on the table, move the head to where you need it to start, and then run the job, and hopefully it fit on your material. Most people just wouldn't go through that trouble. It's just a hassle, and they would just toss the material away, which is fine back then. We've addressed that, so now you can maximize your material. No need to throw material away anymore, because you can tell the machine where this blue dot is. Let's say we want to start on the top left. This blue dot will be placed up here. So there's your blue dot. That's the starting point. In other words, you will position your lens assembly in this corner of your material. It'll figure out how far it needs to go down to run the job. When it's done, it comes back here. Let's say you want to start in the top right. The dot moves over there. I typically use center mode, so to put the head in the center of the material, and it'll figure out how far it needs to go up, do the job itself. When it's done, it comes back to the center. The idea behind that is, again, to make positioning your image on your material simple and to maximize material so you don't throw it away. Okay, click OK on that. The last thing I want to do before I send it to the machine is give it a name. The reason why is that on our machine you can send dozens of files to the machine. The problem is if you don't assign a name to your file, then the default name assigned by the software and the laser is just the word laser. Problem with that is if you have 12 files on the machine that don't have a name assigned to them, they all say the word laser. There's no way to distinguish one file from the next. So it's a good idea to get in the habit of saving your file name, saving your file with a name that's recognizable. In this case, I'll use the word XM8 lasers, which I had made earlier. Save that. I'm going to overwrite it. Yes. And it shows right here the name of the file, including the location. So now when I send this to the laser machine, that file name, XM8 lasers, will be displayed on the material, on this control panel. Now that we have our design, our logo, with the right size, positionings, parameters for engraving and cutting, and speeds, etc., we're ready to send it to the laser machine. On the right hand side, there's a very important button you'll use extensively. What this download button does, it launches a dialog box that's a direct link to the laser system. This shows you the files you have in the buffer right now. Unlike most laser machines on the market, our machine loses power. In other words, you turn the machine off. The files don't get deleted. They stay in the buffer until you delete them, either right here on the delete button, or if none are selected, you can delete all the files in the button in the buffer. And the reason for that is that a lot of times companies will do designs in the late afternoon. They'll send all these designs to the laser machine, shut down for the night. The next morning, the operator just turns on the laser and starts running those jobs immediately. Computer does not have to be on. Those files are still in the buffer until you manually delete those files, either through the control panel, the file manager on the standalone software system or directly on the laser machine itself. That's the beauty of it, because every machine that we get into our warehouse here in Vegas, we put it through a complete testing phase to make sure everything working properly and is giving us the results that we expect. Once we do that, we pack everything up, we ship it to the customer. We want those files to stay on the machine, because once we're at the customer site to set up the machine and calibrate and adjust and get everything prepared, ready to run, and go through the training sequence, we want to make sure before we do anything that the files we ran here in Las Vegas are recreated identically at the customer's location. If it's not, then we know there's something wrong there and we can diagnose and fix it right there on the spot. So this is ideal. Not only does it allow us to make sure we get the same results from Vegas to the customer's location, but also customers that need to do all the designs in the afternoon, morning, what have you, but the operator runs it the next day, those files stay there until you choose to delete them. In this case, we're going to download this particular file that we just created, the XM8 Lasers logo back here, which maintains all of our settings. We can download that, process it. Now it's listed in our queue as well. So that's now ready to run on the laser machine. Okay, the file is installed on the machine. Let's go ahead and grab our material. We just got some simple wood here. It's a cherry wood. And I'm going to go and open up the lid and place the material on the table. Okay. Now what I'm going to do here is I'm going to adjust the positioning of the lens assembly where I want it to begin the job. So first thing I need to do is, as we can see, I'm in the middle of my table here, and I'm going to hit datum. What datum's going to do, it's going to send this button right here. It's going to send the lens assembly to the home position so that it knows where the starting point is of the table itself. And now when I move it by pressing escape here, that unlocks the lens assembly, so I can use these arrows right here to move the head around. And I'm going to move it over to my material. Okay. Now once I get it to where I want it, just hit the enter button 3 times just so that I know that's my new home position. And I'm going to just drop the head down just to show you when I'm out of focus, there's 2 dots there. What I want to do is make those 2 dots into 1. That tells me I am focused to the appropriate distance between the lens itself and the material, which is 2.5 inches in this case. Okay? Now just to show you how this is going to work, there's a laser button here. This manually fires a laser beam. And what I want to do is I want to tell the machine, or I want the machine to show me, there you go, right where the beam's going to fire. Okay? Normally I won't do that in actual production mode. I just want to show you that this, you can manually fire the beam so you can see exactly where you're located at. Okay? Now over here as well on the control panel, there is a button called test. What test button does, when I press that, it shows me if I'm going to fit on my material, which right there shows me I'm not, so I need to move this over a little bit. You can move the head over, move the lens over, whichever works for you. And that shows me I'm still a little bit off. Okay, so let's do that one more time so I can clearly see that I'm going to fit my image directly on the material. Now, in order to run the job, all I got to do is press start, and the job will begin.